Hello. There are a couple other types of exponent rules. We have gone over product rule and quotient rule. Remember, product rule, we add our exponents. Quotient rule, we take the top exponent and subtract the bottom exponent. Then we have to look at them and see if we have negative exponents. So today here we're going to go over a few different types of rules. The first rule is called power rule. It says for any real number with an exponent raised to another exponent, we would multiply their exponents together. So for example, this number a, it has an exponent of m, but it also has another exponent to the n. So what we do is we just multiply these together. So it'd be a to the m times n. So if we try a few examples, it has a base. This first one has a base number of 2, has an exponent of 2, then another exponent of 5. So what we do is we just multiply those exponents together. 2 times 5 is 10. And we could simplify that out, by multiplying to the 10th. These first 4 problems, I just want us to get the process of it down. So the next one, I have 3 to the negative first, then that raised to the 4th. So I take 3 to the negative first times 4. So I get 3 to the negative 4th. Now the thing is, we do not like negative exponents. So where should this exponent go, or where should this term go to make that exponent positive? If you think about it right now, it looks like this. It's this number over 1. So to make that exponent a positive, it would go on the bottom. So 1 over 3 to the 4th. The next example, x to the 3rd, then raised to the negative 2nd, so I just multiply their exponents together. So I get x to the negative 6th. Again, this has a negative exponent, so to make this term have a positive exponent, it needs to go on the bottom, or in the denominator. The last one here, negative 3 times negative 4. So 2 negatives will make a positive, so we'll get b to the 12th. There's our final answer. It has a positive exponent, so we leave it alone. The next type of rule dealing with powers is raising a product to a power. So it says for any real numbers a and b and any integer n, you have to raise each factor or each term to the nth power. Really, all this means is that everything inside the parenthesis gets raised to that exponent outside of it. So here, a and b are both inside the parentheses. So the a gets raised to the nth and the b gets raised to the nth. So let's try a couple examples. This 4, it actually has an exponent of 1. So remember, if a term doesn't have an exponent, that it's just understood to be a 1. So everything inside of here gets raised to the 3rd power. So 1 times 3, which is 4 to the 3rd. X to the 2 times 3, so x to the 6th. Now we're going to multiply these numbers out. So 4 to the 3rd is 4 times 4 times 4. It's not 4 times 3. So 4 times 4 times 4 is 64. Now if you notice, I'm putting a lot of steps here. It's because I'm trying to explain everything. Okay, if you can understand it, going from the first step to the last step, that is, be my guest. That is more than fine. I'm not trying to insult anybody's intelligence. I'm just letting you guys see where we're getting our answer. So this 3 has an exponent of 1. So 1 times 2 is 2. Now I look at the a's. 3 times 2 is 6. Now I look at the b's. 2 times 2 is 4. Last thing, I simplify 3 squared, which is 9. Sorry. You guys should know by now that this tablet isn't always the nicest to me. This next one, we can do the power rule right away. So everything inside here gets raised to the fourth. This is one way. 5, so this exponent, 1 times 4 is 4. This x, 3 times 4 is 12. This y, 5 times 4 is 20. That x, 2 times 4 is 8. So now I need to simplify it. 5 to the fourth is 5 times itself 4 times, so it'd be 625. Now if you notice, here's an x and there's an x. Remember, we only want an x in one location. So this is a product rule. I have to add my exponents. So 12 plus 8 is 20. Once those x's are gone, I'm left with y. Our exponents are all positive, so we leave them where they're at. Another way we could do this is we could have done the product rule first inside. So I'm going to rewrite the original problem and show you another way that we could do this. So here's our answer that we got in this one, in the first way. In this example, I did the power rule, then the product rule. Well, I could do it the other way around. I could do the product rule first, then the power rule. So product rule would be combining my exponents for the same base numbers. So my x's, 3 plus 2 is 5. Now I'll do the power rule. So 5 to the fourth is 625. 5 times 4, x to the 20th. For the y, 5 times 4, y to the 20th. If we look, I have the same exact answer. I just did it two different ways. The last way, the last example here for this slide, I can't do a product rule because I don't have any of the same base numbers, so I have to do the product rule first. So the 2 has an exponent of 1, so 1 times negative 4 is negative 4. A, negative 1 times negative 4 is positive 4. B, 3 times negative 4 is negative 12. Then C, 2 times negative 4 is negative 8. Now look at your numbers there. What do you see that we do not like? Negative exponents for this one, and this one. So we have to move all three of these terms. The a to the fourth has a positive exponent, so it stays on top. 2 to the fourth goes on bottom now, so 2 to the fourth is 16. Then b to the 12th, c to the 8th. Really what we've just done is we've done a quotient rule by moving our negative exponents. The last example is raising a quotient to a power. Pretty much it's just like product rule. Everything inside the parentheses gets raised to that nth power. So we would take everything to the nth power and then look to see if we need to move any of our exponents because of negative exponents. First example. Everything inside here gets raised to the second power. So 2 squared all over 5 squared. So then I can simplify it. 2 squared is 4. 5 squared is 25. I can't simplify that down any farther. So there's my answer. The next one, I could do 3 to the negative third all over 2 to the negative third. And if you notice, I've been putting these numbers in parentheses because it would make a difference if that number inside of there was a negative. Okay? So always put a number in parentheses. So now I have negative exponents. Just think, what do we have to do to these to make them positive? How can I make this 3 to the negative third have a positive exponent? Well, it would go down on the bottom. The 2 has a negative exponent, so it's in the denominator. To make it positive, it's going to go up on the top. Then I just simplify it. 2 to the third is 8. 3 to the third is 27. Because 2 to the third means 2 times itself 3 times. Just like 3 times itself 3 times. Another way we could solve that is we could have flipped these numbers right away because I had a negative exponent. So what I could do is just automatically flip those numbers. Those numbers inside the parentheses, they stay the exact same because all we're doing is we're trying to make this a positive exponent. So it becomes 2 to the third all over 3 to the third. If you look, 2 to the third is 8. 3 to the third is 27. Same exact answer. The next one, I could look to see if I can simplify anything in the parentheses with quotient rule or product rule. I can't, so I can take everything to the negative third power. So I'd have 3 to the negative third. A to the 4 times negative 3, which is negative 12. That's everything on top. Now on the bottom, 2 to the negative third. B to the negative 2 times negative 3 is positive 6. So now I can look at that and say, okay, which ones have negative exponents that need to be moved? This one, the 3, the A, and the 2. So all we have to do is if they're on the top, move them to the bottom. If they're on the bottom, move them to the top. So I'd get 2 to the third on top, all over 3 to the third, A to the 12th, and B to the 6th. Since the B had a positive exponent, it stays on the bottom. Our final answer would be 8 over 27, A to the 12th, B to the 6th. I could have flipped them right away and moved the 3A to the 4th to the bottom, and then the 2B to the negative second to the top, and that would make our exponent positive and work it the same way. Okay, take everything to the third, then decide which ones you have to move. Okay, there are multiple ways to solving these. The last example, I could do the power rule for everything. So I do 2, 1 times 2 is 2 squared. X, 2 times 2 is 4. All over X, 1 times 2 is 2. Then Y to the 6. So then I can figure out 2 squared is 4. Well, I have an X on the bottom and the top, so I can do the quotient rule. So I take the top exponent minus the bottom. So I have X squared. The Y has a positive exponent, so it stays on the bottom. There's my final answer. Another way I could have thought about that is I could have done the quotient rule first. In that first example that I did it here, I did the power rule, then I did the quotient rule. Well, I can do it the other way around. I can do the quotient rule to simplify things first, then the power rule. So I'd take my exponent from the bottom and subtract it from the top. So I'd subtract 1 from 2. So I'd have 2x all over y to the third. Then I square everything. So 2 squared is 4. X to the second all over y to the 6th. Same exact answer, just a different way of thinking about it. There are a lot of different ways that we can do this. There's just not one exact way. Okay? So just take it one step at a time.